Hi guys, today we're going to cover 5.1, which is fundamental identities. An identity is an equation that is satisfied by every value in the domain of its variable. For example, in algebra, two identities are a plus 0 equals a and a times 1 equals a for all real numbers. This means no matter what number you assign to a in this equation, it will always be true, and that's why this equation is called an identity. The following 11 identities are essential in simplifying expressions and helpful with solving equations. They can also be manipulated. These first identities are reciprocal identities, and we've talked about the reciprocal values before, so these should be pretty familiar to you. Sine is equal to 1 over its reciprocal, 1 over cosecant. And then, of course, cosecant would also be equal to 1 over sine. Let me say that more properly. Sine of theta is equal to 1 over cosecant of theta. Cosecant of theta is equal to 1 over sine of theta. Cosine is equal to 1 over secant of theta. And secant of theta is equal to 1 over cosine of theta. Tangent of theta is equal to 1 over cotangent of theta. And cotangent of theta is equal to 1 over tangent of theta. So, all of the reciprocal values, or sine is equal to its reciprocal value over 1, or under 1. Cosine is equal to its reciprocal value under 1, and so on. So since you should know the reciprocal values by now, these ought to be pretty easy for you to remember. All right, for the quotient identities, tangent of theta is equal to sine of theta over cosine of theta. So that's another one that you should be familiar with because we know that tangent is equal to y over x, which we know that in our triangle, y is our sine value and x is our cosine value. So tangent of theta is equal to sine of theta over cosine of theta. And then, of course, since cotangent is the reciprocal of tangent, then cotangent of theta is equal to cosine of theta over sine of theta. And then we have the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. If you can remember that one, you can derive the other two from that identity. Let me show you how to do that. So if we were to take this first one, sine squared theta plus cosine squared theta equals 1. If we were to divide everything by cosine squared theta, well, sine squared theta over cosine squared theta is tangent. All right, so here's tangent. Cosine squared theta divided by cosine squared theta, that would be 1. All right, so well, I don't know if you can see my pointer. Okay, so sine squared theta over cosine squared theta is tangent squared theta. Cosine squared theta over cosine squared theta is 1. And then 1 over cosine squared theta is secant squared theta. So we just took the original Pythagorean identity, divided everything by cosine, and we get this second identity. All right, so then if we were to take the original Pythagorean identity and divide everything by sine, like I've done here, then we can get the third Pythagorean identity. Sine squared theta divided by sine squared theta, of course, is 1. Cosine squared theta divided by sine squared theta would be cotangent. And then 1 over sine squared theta is cosecant squared theta. So now we're going to find the value of sine using the identities. All right, so the first one says cosecant of theta is equal to negative 8 over 5. So let's think about what the relationship between cosecant and sine are. We know that they're reciprocals of each other. So if we were just to take cosecant of theta, which is negative 8 over 5, and flip it, or take the reciprocal of it, then that would be what sine of theta is equal to. So sine of theta is equal to negative 5 over 8. All right, for B, we have cosine, and so we need to think about how we can relate cosine to sine. Well, we have the Pythagorean identity that relates cosine to sine, so we're going to use that. So the Pythagorean identity says that sine squared theta plus cosine squared theta, well, in this case, our cosine squared theta is 3 over 4. So 3 over 4, well, that's not cosine of squared theta, that's just cosine of theta. So we plug in the 3/4 and we square it, because the Pythagorean identity says cosine squared theta, and it equals 1. All right, so now the only variable we have is sine, so we can solve for sine. All right, so we have sine squared theta plus, let me square this, so that would be 9 over 16 equals 1. All right, so then I'm going to subtract 9 over 16 from both sides, minus 9 over 16. So that gives me sine squared theta is equal to, okay, so for this 1, I need to change it to have a common denominator of 16. So 1 would be the same thing as 16 over 16. And then that would give me 7 over 16. All right, and then I'm going to take the square root of both sides. Now, when we take the square root, you know, it can be positive or negative, but this is telling me it's in quadrant 1, so we know that sine is positive in quadrant 1, so it's going to be the positive solution. All right, so if I square the square root, it cancels out, so I just have sine of theta is equal to positive square root of 7 over the square root of 16 is 4. All right, and so that would be my solution. All right, and then for C, it says cotangent is equal to cotangent of theta is equal to negative 1/3, and this time theta is in quadrant 4. Okay, so we don't have an identity that directly relates cotangent to sine, but the Pythagorean identity relates cotangent to sine's reciprocal, which is cosecant. So we have the Pythagorean identity that says 1 plus cotangent squared theta is equal to cosecant squared theta, so that's what we're going to use. All right, so 1 plus cotangent squared theta, which is negative 1/3, squared, is equal to cosecant squared theta. All right, and then we just solve this. All right, so I have 1 plus, when I square negative 1/3, it becomes a positive 1/9 is equal to cosecant squared theta. Okay, so I'm going to do the same thing as I did before and get a common denominator. So I'm going to change 1 to 9 over 9. And then I'm going to add those together, and I get 10 over 9 is equal to cosecant squared theta. Okay, so then I'm going to take the square root of both sides. So this time we're in quadrant 4, and our solution, we're going to try to find sine. So in quadrant 4, all students take calculus. Cosine is the only positive value in quadrant 4, cosine and its reciprocal. So sine and its reciprocal are going to be negative. So this would be negative, or we would have the negative root of that value. Okay, so cosecant squared theta, the square root of that, the square and the square root would cancel out. So we would just have cosecant of theta is equal to negative square root of 10 over 3, because the square root of 9 is 3. And now we just need to flip it to get the value of sine. Okay, so sine of theta is going to be negative 3 over the square root of 10. Well, we can't leave it like that. We need to rationalize it. So we would multiply both the top and the bottom by the square root of 10. And we get sine of theta is equal to negative 3 square root of 10 over 10. Simplifying trig expressions. To simplify a trigonometric expression, we're using the concept of substitution, or replacing terms with their equivalent expression, and order of operations, which you know as PEMDAS. And you want to substitute in an identity that will help you perform an operation of math to reduce the expression to the lowest terms. Now, an important thing to remember is the expression is wrong if you forget to write the argument. For example, theta. If we were to just put sine and not sine of theta, then it's wrong. And that's why I corrected myself earlier whenever I was saying just sine or cosecant. It's sine of theta, cosecant of theta, and if you don't write it that way, then it's wrong. All right, so let's simplify each expression. The first one is 1 over secant of theta. So we want to try to simplify it and write it in something that is equivalent but simpler than what's written. Well, we know that secant is the reciprocal of secant of theta is the reciprocal of cosine of theta. And so this would be equal to cosine of theta. All right, if we think about the quotient identities, cosine of theta divided by sine of theta would equal tangent of theta. So we're just trying to write it in a simpler form. For C, we have 1 plus tangent squared theta. All right, so usually when we see something squared like that, we're gonna refer to our Pythagorean identities. And if we look at the Pythagorean identities, we see that we have a Pythagorean identity that has tangent squared theta and 1. Now, in that identity, the way that it's written is tangent squared theta plus 1 equals secant squared theta. But since we're adding 1 plus tangent squared theta or tangent squared theta plus 1, it's the same thing. And so that would equal secant squared theta. All right, for D, like I said earlier, if we have a square, then refer to the Pythagorean identities. Well, we know that we have a Pythagorean identity that has 1 and cosine squared theta, and the Pythagorean identity that has cosine squared theta is sine squared theta plus cosine squared theta equals 1. Well, if I were to subtract cosine squared theta from both sides, then I have 1 minus cosine squared theta, which is what we have here. And we can see that that is equal to sine squared theta. All right, for E, we have secant of theta divided by cosecant of theta. Well, we know that those have reciprocal values. We know that secant of theta is equal to 1 over cosine of theta. And we know cosecant of theta is equal to 1 over sine of theta. Well, this is a fraction divided by a fraction. And we know that we can't divide fractions by fractions. We have to multiply by the reciprocal. So this would be the same thing as 1 over cosine of theta times sine of theta over 1. Okay, so then that would be sine of theta over cosine of theta. And sine of theta over cosine of theta is tangent of theta. So another tip here is to, well, like I said, if you have squares, think about the Pythagorean identities. In other trig expressions that you're trying to simplify, if it's not in terms of sine and cosine, get it in terms of sine and cosine, and usually that'll help you to reduce it or simplify it. So for f, we have sine of theta is equal to cosecant of theta. So for the cosecant of theta, let's change it to into terms of sine or cosine. Well, we know that cosecant is the reciprocal of sine. All right, so sine of theta is going to stay the same, and then I'm going to change cosecant of theta to 1 over sine of theta. Well, now if I multiply that together, I get sine of theta over sine of theta, which just equals 1. All right, let's look at G, and we're going to do the same thing. Let's change anything that we can into terms of sine and cosine. Well, secant of theta is equal to 1 over cosine of theta. And then we have sine of theta. And then cosecant is 1 over sine of theta. So these sines would cancel, and then I just have 1 over cosine of theta, which is secant of theta. All right, for H, I see some squares, so let's see if we can relate this to a Pythagorean identity. And I know that if we think about the Pythagorean identity that has cosecant in it, let me write that one out. So cosecant or the Pythagorean identity with cosecant of theta is 1 plus cotangent squared theta is equal to cosecant squared theta. So to get this, if I subtract 1 from both sides, that means that this cosecant squared theta minus 1 is equal to cotangent squared theta. So let me replace this cosecant squared theta minus 1 with cotangent squared theta. All right, so I have sine squared theta times cotangent squared theta. Okay, so now let me turn cotangent squared theta into terms of sine and cosine. Well, even though these are squared, cotangent squared theta, or cotangent of theta, is equal to cosine over sine. Cotangent squared theta would be equal to cosine squared theta over sine squared theta. So now when I multiply these together, these sine squared thetas would cancel, and my answer is just cotangent squared theta. So I wish we were in the classroom together so somebody could holler at me and tell me that I'm wrong. Okay, so I don't know, I guess because I wrote cotangent up here, that was in my brain. So cotangent is not equal to cotangent squared theta over sine squared theta. It's equal to cosine squared theta over sine squared theta. So there we go, that's better. And so that equals cosine squared theta. That's better. All right. Here's another one. I don't see any squares, so let's change it into terms of sine and cosine. Tangent of theta is equal to sine of theta over cosine of theta. And cotangent is the reciprocal of that, so that's equal to cosine of theta over sine of theta. All right, and if you'll notice, this is in parentheses. So we're distributing this tangent into these parentheses. Okay, so these two would get multiplied together, plus tangent of theta times tangent of theta, so that would be tangent squared theta. All right, so now if I multiply sine of theta over cosine of theta times cosine of theta over sine of theta, these cancel and I just get 1. Anything divided by itself is 1. So that's 1 plus tangent squared theta. So now that we have a 1 and a square, let's think about the Pythagorean identities. Well, if we look back at the Pythagorean identities, 1 plus tangent squared theta or tangent squared theta plus 1 is secant squared theta. And that's our answer. All right, for the next one, I have some squares in here, so let's think about Pythagorean identities. Well, I know that sine squared theta plus cosine squared theta, that is a Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So I can just put those together. Those would equal 1. And then I have this plus tangent squared theta left. And 1 plus tangent squared theta or tangent squared theta plus 1 is secant squared theta. All right, for the next one, let's change secant into terms of sine and cosine. Well, I know that secant is the reciprocal of cosine, so 1 over cosine of theta minus cosine of theta. Okay, so here I'm trying to subtract these. Well, I can't subtract them unless I have a common denominator. So to get a common denominator, you know, this is understood to be over 1. If I were to multiply both of these by cosine of theta, that gives me 1 over cosine of theta minus cosine squared theta over cosine of theta. Okay, so then that's 1 minus cosine squared theta over cosine of theta. Well, we know in the Pythagorean identities, 1 minus cosine squared theta would be sine squared theta. So we have sine squared theta over cosine of theta. So just one of those. So sine squared theta would be the same thing as sine of theta times sine of theta. Over cosine of theta. All right, so this right here would be the same thing as tangent. So this gives me tangent of theta times sine of theta, and that's as simple as we can go. All right. When I look at L, cosine squared theta minus sine squared theta, that makes me think about the Pythagorean identity, but that's not a Pythagorean identity because the sine squared theta and the cosine squared theta are being added together in the Pythagorean identity. So that we can't change that to 1. If this were a plus in between those, then that would equal 1, but it's not, so it doesn't. So let's separate these into two separate terms. we can say that cosine squared theta over sine of theta cosine of theta minus sine squared theta over sine of theta cosine of theta. Okay, so we can separate it like that. Now that it's separated, we can reduce. We couldn't reduce with them together because there was a minus in between it. If there's a plus or minus in between terms, we can't reduce. So now that we've separated it within each separate term, we can reduce. And I can reduce this by cosine, and one of these cosines would cancel out. So I'm left with cosine of theta over sine of theta. And then the same thing in the next term, one of the sines would cancel out. So that leaves me with sine of theta over cosine of theta. Okay, well, cosine of theta over sine of theta is the same thing as cotangent of theta. And then sine of theta over cosine of theta is the same thing as tangent of theta. And then we're done.